Hi everyone, welcome to the linear or quadratic table worksheet. It asks us to write a function rule for each table and then determine if the data is linear or quadratic. Well, let's remember that linear, one of the forms we know for linear equations is slope-intercept form, and that's y equals mx plus b, and quadratic is y equals ax squared plus bx plus c. And the form for a quadratic equation should be written in your little book that you made yesterday. And another thing that I need to remind y'all is you need a calculator for this worksheet, so make sure that if you don't have one, you run to the back and grab it. So if you remember in our little book yesterday, we looked at the differences in our y values, and that's what we're going to look at to determine if these tables are linear or quadratic. So let's look at the difference in our x values. So our x values here, to get from -2 to 0, you have to add 2. And to get from 0 to 2, you add 2. And from 2 to 4, you're going to add 2. Now let's look at our y values. To get from 5 to -3, we add, or subtract 8, sorry about that, subtract 8, and to get from -3 to 5, we add 8, and to get from 5 to 29, we add 24. So when we're doing that, we realize that this is our first difference, and our first difference is not the same. So we have to go ahead and look at our second difference and see if that's the same. Well, to get from -8 to 18, we have to add 16. And to get from 8 to 24, we have to add 16. Well, now our second difference is the same. Therefore, when our second difference is the same, it's quadratic. So now we are asked to come up with this equation, and it gives us y equals, and we have to come up with the rest of it. And this is where the calculator part comes in. So we're going to go ahead and go into our calculator, and we're going to type in our data. So let's go ahead and turn your calculator on and go to a new document, and we're going to add list and spreadsheets. And up in our A box, remember up in our A box of our listing spreadsheets, we put X, and in our B box, we put Y. And the data for that problem number 1 that we were doing was -2, 0, 2, and 4 for our X values. And for the Y values, it was 5, -3, 5, and 29. So we've entered our data. Make sure that you go ahead and do that. I'm going to give you a couple seconds. And we know that this table is going to give us a quadratic equation. So now we just have to do that. So find that equation. And the way we're going to do it is we hit Menu, we go to Statistics, and then Stat Calculations. So once again, we hit Menu, Statistics, and then Stat Calculations. Now we're used to going to linear regression where we have mx plus b, but remember this time we're dealing with a quadratic table, so we're going to go down to quadratic regression. And you're going to select that, and now you're going to have to change your X list. So the way you're going to do that, your X list, you hit the right arrow button, and a drop-down menu should come up. And then you're going to hit the down arrow to X. So your X list should be labeled X. Go down to your Y list, hit the right arrow button to get the drop-down menu, and then go down to Y. Okay? So your X list should be X, and your Y list should be Y. You can hit Enter. And now this lovely stuff comes up off on the side. Well, if you notice, they give us an A value of 2, a B value of 0, and a C value of -3. So we can go back to our worksheet. And we know, remember, quadratic is ax squared plus bx plus c. Well, in this case, our a value is 2, so I'm going to replace a with 2. And then I write x squared Our b value was 0, so I replaced b with 0, 0x, and then our c value was negative 3. So our equation for number 1 is y equals 2x squared plus 0x minus 3. Well, 0 times anything, this 0 times x is 0, so we can make it disappear. So all that we're left with is 2x squared minus 3 for our equation. Okay? So now let's go on to number 5. Problem number 5. And let's look and see if we can determine if it's linear or quadratic. Well, our x values are consistently increasing by adding 3. To get from 3 to 6, we add 3. To get from 6 to 9, we add 3. And to get from 9 to 12, we add 3. Our y values, on the other hand, are to get from negative 9 to negative 18, we subtract 9. To get from negative 18 to negative 27, we subtract 9. And to get from negative 27 to negative 36, we subtract 9. Well, if you notice, that's our first difference. So the first difference is all the same. So therefore it is linear. Okay, so we can go to our calculator again and enter in our data. So I'm going to go to a new document. Whenever they ask you to save, you say no. You go to add list and spreadsheets. And then in our A box we put X. In our B box we put Y. And then we enter our data 3, 6, 9, and 12. And then we put in negative 9, negative 18, negative 27, and negative 36. We hit menu, statistics, stat calculations. We label our X list X and our Y list Y. And then you hit enter. Oh, I'm sorry, I didn't even explain. Notice I chose linear regression, and I chose the wrong one. Let me back up. Sorry. Give yourself a couple pizza points if you want. I've entered my data. I hit menu, statistics, stat calculations. Now, last time I chose quadratic regression because we knew our table was going to be a quadratic equation. This time, I choose linear regression in the mx plus b one. And so, because we know that this equation is going to be linear because the first differences were the same. So I hit linear regression. I label my X list X and my Y list Y. And I hit OK. And now I get this lovely stuff on the side again. And the things that you need to note are that M is negative 3 and B is 0. So I go back to my worksheet. And remember, a linear equation is y equals mx plus b. That's slope-intercept form. So y equals, our m value was negative 3, so I replace m with negative 3. And then our b value is 0, so we add 0. And remember, adding 0 is like nothing, so we can even erase it. So our equation is y equals negative 3x. Okay, let's try one more. Let's go to problem number 4. Let's change it up. Our x values are increasing by 3 each time. And our y values, to get from 43 to 16, you have to subtract 27. And to get from 16 to 7, you subtract 9. And to get from 7 to 16, you add 9. And to get from negative 27 to negative 9, you add 18. And to get from negative 9 to positive 9, you add 18. Well, if you notice, our second difference is the same. So our equation is going to be quadratic. So now I'm going to go to my calculator. I go to a new document, hit no to save. Go to add list and spreadsheets. In A I put X, and in B I put Y. And then I type in my data. And my data this time is negative 4, negative 1, 2, and 5. My y values are 43, 16, 7, and 16. And we have to remember that our second differences were the same this time. So we're looking for a quadratic regression. And I get there by hitting Menu, Statistics, Stat Calculations. I go to my X list and I hit X. I go to my Y list and I select Y. I hit Enter, and then look, it gives me, I even hit linear regression again. Sorry. Menu, Statistics, Stat Calculations. I don't know why it's not letting me do it. Menu, Statistics, Stat Calculations, and then Quadratic Regression. X list is X. Y list is Y. And you hit OK. Well, mine's a little off to the side, but you still get the A value is 1, the B value is -4, and the C value is 11. So you go to your worksheet, and we write y equals ax squared plus bx plus c. And our a value this time was 1, so it's 1x squared, plus our b value was -4, so it's minus 4x, and then our c value was positive 11. So my equation, we don't have to write a coefficient of 1 because it's assumed that it's there if there's nothing written. So we can just write x squared minus 4x plus 11. And that is number 4. So the key to remember is that the second difference means quadratic if it's the same. And if the first difference is the same, you hit linear. Ignore that bell. Okay, so now, once you've done that, you go in and either do a linear regression or a quadratic regression in your calculator. All right, let's go down to number 10. It says build a table or write an equation to determine if each situation is linear or quadratic. Number 10 says Ray works at an ice cream store and he earns $6 an hour. Well, for 1 hour, he earns $6. If he works 2 hours, he earns $12. And if he works 3 hours, he'll have earned $18. We look at the first differences. So this is my x and this is my y. And to get from 6 to 12, we add 6. To get from 12 to 18, we add 6. So the first differences are the same. So it is a linear equation. Okay, now let's look at number 11. It says the area of a square is written in terms of the length of a side. Well, we know the area of a square is side length squared. And that formula should be on your formula chart. Or if you look above the board, it's up there. So area is side length squared. And because they have a variable that is squared, this equation has a degree of 2. The highest exponent is 2. Therefore, it is quadratic. All right, let's move on to number 12. Number 12 says the perimeter of a regular hexagon in terms of the length of a side. Well, regular hexagon, a hexagon has 6 sides, and regular means that they're all the same. So 6 sides that are all the same length. In perimeter, you're adding up all of the sides. So if the side length was x, we would be adding x together 6 times, which when you add 6 x's together, it gives you 6 times x. And so this would be the equation. Perimeter equals 6 times x would be the equation for our perimeter of a regular hexagon. And we know that this is linear because there is no exponent being squared, or this equation does not have a degree of 2. The highest exponent is 1, so we know it's linear. Okay, your responsibility now is to finish this worksheet, and you definitely have time to finish it in class. And you need to do your first part first. Do the front part first because you need your calculators for that front part. If you finish this in class, no homework. So make sure you hold on to it and make sure you get this done to turn it in. All right, y'all have a great one, and I will see you tomorrow.